Hi you guys, it's Mrs. Palmer and my family is heading up skiing today. In the back you'll see that's my oldest son Jackson. Benton's there in the Sendo Vision, and then if you look this way you can see my daughter Rue, and then here is my husband Mo. He's the more serious one in the family, but today in math we're going to do graphing stories, so I want you guys to follow our adventure skiing. Okay, so this is us driving to the ski resort. My husband is traveling, how fast would you say you're traveling? 65 miles per hour. Okay, so now we are approaching the turn for Snowbasin Ski Resort. You can see that our car is slowing down. We're now going 30 miles per hour as my husband takes a left. Now we're going 10 miles per hour. And Snowbasin is in 3 miles. As we go up this hill, our truck continues to increase in speed until we reach the speed limit, which is 45 miles per hour. Okay, so we can see that Snowbasin is in a quarter of a mile. Our speed has dropped a little bit to 30 miles per hour. Okay, so we have arrived. Welcome to Snowbasin. As we make this left-hand turn right here, our speed is dropping again. You can see that the speed limit is 25 miles per hour. Okay, so we've arrived. We're going to be looking for a place to park here. Our speed has dropped way low. We're going about 5 or 10 miles an hour. Hey, are you guys leaving?
No, we're not.
Okay.
Not yet, sorry.
Thank you. Okay, right now we're just sitting still. We're waiting for this guy to pull out so we can take his spot. Okay, we're gonna slowly back into this parking spot. You can see our truck is not moving very far, very fast. Okay, you guys, who's ready to ski? Okay, so now everyone is about ready to go. We need to grab our skis. It has taken us about 10 minutes here in our parking spot. Okay, so here we are ready to go. Clint and I are walking up to the lift right here, the gondola. Look how beautiful it is. It's going to be some lots. So here we are, walking across the plaza here at Snowbasin. We are going to take a lift called John Paul. Okay, well, looks like the John Paul lift is closed. So we're going to go back in the other direction across the plaza and ride the needle express. Wait to be skiing today. We got our skis on.
You want a picture of that? What are we
doing now? Slowly making our way.
We should just go down sleep. I want to go do that turn. Oh, Brock wants to go hit a jump though on. He wants to go around the cat.
Right above all the clouds. Version today. Pause for a picture. Hey! Here we go. We're off. Okay, so let's go ahead and graph the story of my family and I going skiing. The first thing that we need to do is set up our coordinate plane. Okay, for this particular story, we are going to call the x-axis, remember that is going to be our independent variable. We are going to call this time. And our y-axis, the vertical axis, that is our dependent variable. And we are going to go ahead and call this distance. Okay, so let's just go ahead and think about our skiing adventure. Okay, so let's say we start at time 0 right here. Okay, so at time 0, we haven't traveled any distance. The video started with us in the truck, and we were traveling along the road at 60 miles per hour. And you know that a car can't just go instantly from 0 to 60 miles an hour. So as time passes, our distance is going to increase. Okay, and this line is going to get a little bit steeper and a little bit steeper and a little bit steeper until we are moving at our maximum speed. And actually, I want to back up here just a little bit. Let's put some frames of reference for our distance. So let's say that this is 5 miles and this is 10 miles. And this is 15 miles, which is the distance that Snowbasin is away from our home. And then let's say that this is 20 miles. Okay, so if we start from time 0 and distance 0, and we head to Snowbasin, okay, as time passes, our distance is going to continue to increase. Okay, when we were going 60 miles per hour, that would mean our slope gets a little steeper. Okay, so our distance over time increases. Now, I would say that the ski resort is about 12 miles away from where we live. So as we get closer to the ski resort, time is passing, but we're not covering as much distance. So the slope of our line is not slanted as much. Okay, and then we get to the parking lot. And in the parking lot, time is increasing, but our distance really isn't increasing very much. Okay, it's pretty much staying still. And then we park, and our distance isn't increasing. So you can see as time passes, our distance isn't increasing. Okay, and then as we get our skis on and we head to the lift, time is passing, but we're not really getting very far very fast on our feet. Okay, so our distance is not increasing very much. You can see that our slope here would be like barely slanted in the positive direction. And then we get on the gondola, and again our distance over time, the slope of that continues to be a little steeper. Okay, and I would say it's about 5 miles to the top of the mountain. And then we get to the top of the mountain, and as we're putting our skis on, time's passing, but we're not covering any distance. And then as we start to ski, time is passing and our distance is increasing. Okay, there was a spot on the hill where we stopped. So again, time would be passing and our distance would not be increasing. And then as we started to ski again, our distance would increase. Okay, so this is a really rough sketch of our Palmer ski adventure. The most important thing that I want you to notice here is that there are certain points along this graph where the slope is a lot steeper than other points. Okay, and there are certain points on this graph where time is passing, but there is no increase in distance. Okay, so when we're in the parking lot, time is passing, there's no increase in distance. When we are putting our skis on at the top of the hill, time is passing, there's no increase in distance. When we are stopped at the top of the hill for a minute, time is passing, that there is no increase in distance. And then the slopes of these different parts of our graph, you can see that they're all changing based on what we're doing at that particular time. And the more distance we're traveling over the smaller amount of time, that is going to make the slope at that particular part in the graph steeper. Okay, so if you're not covering very much distance over a certain amount of time, your slope is going to be smaller. Okay, so let's go ahead and look at two different lines here. Y equals 5x plus 1 and y equals 1x plus 1. Both of these lines are in slope-intercept form. You can see that the slope of this line is 5 and the slope of this line is 1. So if I were to graph these lines on this coordinate plane, this is our x-axis, this is our y-axis. This line right here crosses the y-axis at 1, and then the slope would be up 5, 1, 2, 3, 4, 5, to the right 1. Okay, so this would be one line. And then we have another line here, y equals 1 times x plus 1. So this line would cross the y-axis at 1. The slope is up 1 to the right 1. Okay, so you can see that a line that has a bigger slope is going to be a lot steeper than a line that has a smaller slope. So we're going to spend the remainder of this lesson just looking at some stories. And the big question that I want you to think about for each of these stories is, what is being graphed? Okay, so when we read through this, Dylan rides his motorcycle from his home to his friend's home 125 miles away. The graph at the right shows his journey. Write a story that will represent his trip. State the fastest average speed he maintained for at least 1 hour. Okay, so here's the story. And if we ask ourselves what is being graphed, we can see on this x-axis here, we have time. Okay, and this is our independent variable. And then on our y-axis, we have distance, and that is going to be our dependent variable. So let's just go ahead and take a look at what's happening here. So from 0 to 1 hours. Okay, we can see that from 0 to 1 hours, the motorcycle traveled 25 miles. And then from 1 to 2 hours, we can see that the motorcycle traveled 50 miles, right? So we can see at this point in the graph, okay, he's moving a lot faster, isn't he? Because he traveled 50 miles there, and he only traveled 25 miles there, okay? And then let's look at what's happening between 2 and 3 hours, okay? So between 2 and 3 hours, it looks like his distance didn't increase at all. It looks like it stayed the same. So maybe he was taking a break here. Maybe he was eating lunch or eating dinner. Who knows? Maybe he was visiting another friend along the way. But, and we don't know that part of the story. All we know is that from 2 to 3 hours, his distance did not increase. And then from 3 to 5 hours, okay, from 3 to 5 hours, we can see that he traveled another 50 miles. Okay, so then A says to write a story that will represent his trip. So we can say that Dylan starts off his trip and he is traveling on a slow mountain road. And then he gets to a fast highway. And then he gets off at an exit and has lunch. And then he gets back on the fast highway, but he decides to drive a little bit slower than he was moving before lunch. Okay, so that would be an example of writing a story that will represent his trip. B says, state the fastest average speed he maintained for at least 1 hour. Okay, so we know that between 1 and 2 hours, okay, between 1 and 2 hours, we can see that he traveled 50 miles. So he traveled 50 miles in just 1 hour's time, right? From here to here, that's 1 hour. And we can see that the distance that was increased was 50 miles. So that means that right there, he was traveling 50 miles per hour. Okay, let's look at another story. Remember, we are looking at what is being graphed. So it takes Ariel 60 minutes to reach the hiking team's campsite, following a trail depicted in the graph at the right. Write a story that will describe his hiking journey. What is the change in elevation between Ariel's starting point and the campsite? Okay. So now let's look at what is being graphed. We can see on our x-axis we have time. In our y-axis we have elevation above sea level in feet. So if we're starting right here, we can see that the elevation is at 5 feet. Okay, that's the elevation when Ariel starts his hiking journey. Okay, now from 0 to 10 minutes, we can see that the elevation doesn't increase. Okay, so we can say that Ariel's traveling along a flat road. Okay, the elevation isn't increasing. He's not going up at all. Okay, but from 10 to 20 minutes, we can see that the elevation increases from 5 to 10. Okay, so that would mean that he's going up a little bit of a hill right here consistently for 10 minutes. And then from 20 to 30 minutes, again, the elevation isn't changing. And now from 30 to 40 minutes, we can see that the elevation is actually dropping. So that means he's going back down, probably a little small hill there. Okay, and then from 40 to 50 minutes, we can see that the elevation is increasing a lot right here, isn't it? It's going from 5 to 25 in just 10 minutes time. So this is probably a pretty steep little hill right here. Okay, and then again, Ariel is back on a flat road, but at a higher elevation than he started off with. Okay, and then we have a question B. What is the change in elevation between Ariel's starting point, which is at 5, and the campsite, which is at 25? So we would say there is a change, okay, from 25 to 25, there's a change in 20 feet. Okay, now I do want us to look at the slope between the different parts of this graph. Okay, so from here to here, our slope is going to be 0, right? There is no change in our steepness. From here to here, though, it looks like there's a change of 5 in elevation for a change of 20 minutes. Okay, so remember, this is our x-axis, this is our y-axis, and so remember when we talk about slope, slope is the change in our y-axis over the change in our x-axis. So the change in our y-axis right here is from 5 to 10, so that would be a positive 5, and the change in our x-axis would be 10. Okay, and remember our red line, our slope was 0. Okay, let's look at this piece right here. Okay, again, there is 0 change in the y-axis. So even though time is passing, there is 0 change in our y-axis. So that means our slope would be 0. On the next point in our graph, we'll do this one in purple. We can see this time we're actually going from 10 back down to 5. So our change in our y-axis would be negative 5 over positive 10. Trying to find a color I haven't used before. Let's use yellow. Okay, so for this part of our graph, okay, we can see that the change in our y-axis is from 5 to 25. So that is going to be a positive 20 over 10. Okay, and then the last part, again, trying to find a color I haven't used yet. So this last part, we have a slope of 0. Okay, so what is the change in the elevation between Ariel's starting point and the campsite? We already figured that out, didn't we? It would be 20. And you can see that the different parts of this graph have different slopes, don't they? Each part has its own slope. Okay, so let's go ahead and look at this next story. Lynn usually has her bangs cut every 3 months. The graph at the right shows the growth of her bangs over the past year. Now, I don't know if any of you have bangs, girls, or if you've tried to have bangs in the past, but they are super annoying to keep trimmed, and they're super annoying to grow out. Okay, so if you have had bangs in the past, you know exactly what I'm talking about. So when we look at this story, though, Lynn usually has her bangs cut every 3 months. The graph at the right shows the growth of her bangs over the past year. Write a story to describe her bang lengths for the past year. Does the graph indicate that Lynn's bangs continue to grow at a consistent rate? Explain. Okay, so let's do part A here. First, let's figure out what's being graphed. So you can see that on the x-axis, remember that's always our independent variable, so that's time. And on our y-axis, we have the length of her bangs in inches. Okay, so let's look at the first part of this graph here. Okay, so from 0 to 3 months, we can see that her bangs grew 3 inches. Okay, so let's just go ahead and let's color this right here in mint green. And we can say the change in our y-axis is 3 over the change in our x-axis is also 3. Okay, so that means our slope would be a slope of 1. Okay, let's use another color for the next piece of our graph here. Okay, so from 3 months to 9 months, okay, we can see that her bangs grew 1, 2, 3, 4, 5, 6 inches. Okay, so 6 inches over the course of 6 months, right? You can see 6 inches over the course of 6 months, because from 3 to 9 months is 6. Okay, then let's go ahead and look at the last piece of this graph here. We'll do that one in purple. Okay, and we can see that from 9 to 12 months, her bangs grew 1, 2, 3 inches in 3 months. Okay, now we know that 3 over 3 is 1. 6 over 6 is 1. 3 over 3 is 1. So this says, does the graph indicate that Lynn's bangs continue to grow at a consistent rate? Explain. And we would say yes. All of the lines that we have graphed here, they all have the same slope, don't they? Another thing that I want you to notice about this graph is all 3 of these lines are parallel. Okay, so whenever you are talking about 2 parallel lines always have the same slope. Okay, so let's go ahead and look at this next story. Trip to the mall graph story. Maritza took the Metro Rail to go shopping downtown with her friends on Sunday. Use the graph to answer the following questions. What is the independent variable? What is the dependent variable? What is the domain? And what is the range? Okay, so when we look at what is being graphed here, we can see that this is the graph of her trip to the mall, right? And the x-axis is time in hours, and the y-axis is the distance from the station. Now, we've been talking about the fact that our independent variable, that is our x-axis. Okay, so in this case, our independent variable is going to be time. And then what is the dependent variable? Okay, well that's our y-axis. So in this case, our dependent variable is the distance from the station in blocks. Now the next question says, what is the domain and what is the range? So remember the very second lesson that we had in this unit on linear relationships, we talked about domain and we talked about range. Okay, remember the domain, that is our x values, and the range is our y values. So when we look at this graph right here, can you see that our x values go from 0 to 2 1/4, I believe that is? So that's what our domain would be. Okay, our domain would be from 0 to 2 1/4. And then our range, we can see that the highest that we go as far as our range is concerned is up to 6. Okay, so our range would be from 0 to 6. Okay, we're going to do one more of these together, and then I'm going to have you guys practice a couple of these on your own. So for this one, this is a little bit of a challenge, but I know you guys can do this. So what is being graphed? We have been given that y equals -1x plus 3, and y also equals 2x minus 12. And then we have these values right here. So we're going to go ahead and pay attention to those in just a second. Part A says to graph the function. Part B says to state the domain, the x values used. So let's go ahead and just graph this function first. So we're going to graph the line y equals -x plus 3. Okay, we can see that this equation is already in slope-intercept form. So we're going to graph y equals -x plus 3. We'll do that one in red. And then we're going to graph the other line, y equals 2x minus 12. We're going to graph that one in blue. Okay, so let's go ahead and graph our first line. Y equals negative x plus 3. Both of these equations are already in slope-intercept form, so that makes it really easy for us to graph. We know the red line's going to cross the y-axis at 3. The slope is -1 over +1. So that means we're going to move down 1 to the right 1, down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. Okay, and then here's our line right here, and we'll do that in red. Okay, and then our blue line, y equals 2x minus 12. Okay, so this one crosses the y-axis at -12. Okay, it's also already in slope-intercept form, so it crosses the y-axis at -12. The slope for this one is 2 over 1, so up 2 to the right 1, 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 up 2 to the right 1. Okay, I think that's probably far enough here. Okay, so here's our blue line. I better have that go a little bit further here. And I also need to make sure that I do arrows on both ends of my line. Remember that lines extend forever and ever in both directions. So make sure I add my arrows here. Okay, now for each of these lines, we were given some restrictions here. Okay, so can you see that when we graph this, y equals -x plus 3, we're talking about the piece of the line that is bigger than or equal to 0, but less than 5. So we talk about the part that is bigger than or equal to 0, but less than 5. Okay, and it actually includes this part right here. Okay, so this black part, that's what we're talking about as far as the line y equals -1x plus 3. On the blue line, I'm going to do this in the color green. Okay, so for the blue line, we're talking about bigger than or equal to 5, but less than 8. So bigger than or equal to 5, but less than 8. Would be right here. Okay, so notice that on the parts where it's just a less than, I did an open circle because it doesn't include that. Okay, on the parts where it's less than or equal to, we do a solid circle. Okay, so this is the graph of our function. And our next task is to state the domain, so the x values. So if we're talking about our domain here, we can see that, and this is our function right here. Okay, so we can see that our domain stretches from 0 to 8. So it has to be all x's greater than or equal to 0 and less than 8. That would be what our domain is. And when we write that, we would include the 0, and then it extends to 8, but because it's less than the 8, we include just a parenthesis and not a solid bracket. Okay, you guys, so I know that this was a rather long lesson, and I hope you're able to follow along and take notes in your note guide. Your task is to do question 1 and question 2 on this quiz on your own. Question 1, you are just matching a graph to a story. Okay, so you're figuring out which one of these, A, B, or C, matches with the graph that is shown here. And on question 2, Grandma is baking a cake. For the 7 labeled times on the graph, explain what is happening in the oven. So for this, I want you to pay careful attention to the fact that this is your time, and then this is your temperature. Okay, so at different parts along this graph, I want you to look at what's happening at those particular times. Okay, what's happening to the temperature? So on your paper, you should have 1, 2, 3, 4, 5, 6, and 7. And I want you to make some observations about this graph and what is happening in the oven. Okay, so with that said, this is the very last lesson of Unit 3. So after this, you guys will be ready for your review and then your Block 2 test, and then you will be all done with Block 2. So hopefully you guys are finishing this up before Christmas break. If you have any questions at all, please make sure that you email me or call me or text me. If you need some help in class with this, raise your hand and we'll put you in a breakout room and help you individually with whatever you need. Have a great day.